let's take next. What is the next one trying to say? Show that A, B, C and D are vertices of square. So this time we are being asked to prove square. Earlier it was parallelogram, now it's a square. How we are going to, and with what? As I said, definitions and properties. So very first thing is, without thinking further, what is the main property of square? All the sides are going to be equal. So first, without thinking, let's start. When I say all the sides are going to be equal, that means I have to make use of distance formula. Before that, if you want, you can just draw a square. If you want, you can just draw a square and simultaneously write down the coordinates also. You know, not draw it that much with precise. A, B, C, D. A, 4 minus 1. B, 6, 0. C is 7 minus 2. D is 5 minus 3. Here this is x1, y1, x2, y2, x3, y3 and x4, y4. Let's start our solution with the same, absolutely in the same way. Solution. Let A 4 minus 1, B 6, 0, C 7 minus 2 and D 5 minus 3 be the vertices, mind you, as of now, not square, quadrilateral ABCD. Quadrilateral ABCD. You can always make use of symbol of quadrilateral. You can always make use of symbol of quadrilateral. What we have said we are going to do, so we are going to find out the distance. So we are going to find all the distances, and if all the distances happens to be same, then it's a square. The argument continues. Sir, it could be rhombus also. I'll come to that. So let's start with AB. Using distance formula, first distance AB, under root of, you need not write down the formula, you can directly go with, so x2 minus x1 the whole square plus y2 minus y1 the whole square, so it is going to be 6 minus 4 the whole square plus 0 minus of minus plus 1 the whole square. 6 minus 4, 2, square of that 4, 1 square 5, sorry, 1 square is 1, total is 5, I'm sorry for that. 1 square 1, total is root 5, equation number 1. B, do write down units, root 5 units. Please do write down units. Distance AB is root 5 units. On the same lines, also, distance BC we go with. Distance BC, direct answer. What is that going to be? 7 minus 6 the whole square plus minus 2 minus 0 the whole square. 7 minus 6, 1 square is 1. Minus 2 minus 0 is minus 2 square. Minus 2 square is 4. Root 5 units. Equation number 2. That's distance BC. What next, children? What next? Absolutely on the same line. Distance CD. So also distance CD. Distance CD. Answer is going to be 5 minus 7 the whole square plus minus 3 minus of minus plus 2 the whole square. 5 minus 7 minus 2 square plus minus 1 square. Minus 2 square 4 minus 1 square 1. Root 5 units. Equation number 3. So that's distance CD. Finally, also distance AD. Also distance AD. 4 minus 5 the whole square. 4 minus 5 the whole square plus minus 1 plus 3 the whole square. Minus of minus plus 3 the whole square. 4 minus 5 minus 1 square. 2 square. Minus 1 square 1. 4 root 5 units. Equation number 4. That's distance AD. What did I notice and what did I realize? 1, 2, 3, 4. All of them root 5. All of them root 5. I'm coming to that particular argumentative question which you people have it right now. I'm coming to give you the answer. So from equation 1, 2, 3 and 4. Distance AB is equals to distance BC is equals to distance CD is equals to distance AD. If you want, you can write down 4 units. I'm really sorry, root 5 units. Root 5 units. We are not done. So at this juncture, I never claimed also that it's a square, because even I am aware that this property of all the sides being equal belongs to rhombus as well. So how I made you understand that from a parallelogram how one can convert into a rectangle. Here I am going to make you understand what is the difference between a rhombus and a square. The point of similarity is that both of them, rhombus and square, all sides are equal. So at this juncture I can claim this as rhombus as well, at this juncture, mind you. Now what is the difference between rhombus and square? In rhombus, the interior angle is not 90, and in square the interior angle is 90. That means if I happen to prove at this juncture any one angle as 90, for that matter A, B, C, D, any one 90, I can say it's a square. What is the other way around? In rhombus, the diagonals are also not equal. In square, the diagonals are equal. So if I have all 4 sides equal, if I have all 4 sides of a quadrilateral equal and diagonals unequal, it's a rhombus. And if I have all 4 sides equal and diagonals equal, then it's a square. I hope you understood. So for square, there are 2 ways to distinguish. Any one interior angle has to be 90, and I told you how to get 90, converse of Pythagoras theorem. But I feel that rather going there, we just happen to find out the diagonals AC and BD. If the diagonals are equal, along with the sides being equal, diagonals equal, it's a square. With sides equal, diagonals unequal, it's a rhombus. I hope my children have understood this, right? So now what we are going to do is, we are going to find the diagonals. Now, length of AC, length AC or distance AC. If you want, since in the entire sum we have gone with distance, so distance AC. Distance AC, what I will write down? Distance AC is under root of, I shall say 4 minus 7 the whole square plus minus 1 minus of 2 the whole square. So answer is going to be 4 minus 7 minus 3 square is 4 minus 7 minus 3 square is, come on, 9, and plus minus 1 plus 2, 1 square, 10, root 10. 4 minus 7 minus 3 square. If you want, I'll write down this way. If you want, I'll write down in this way. Minus 3 square plus 1 square under root of 9 plus 1 under root of 10 units. This is distance AC. Equation number 5. On the same lines, also, distance BD under root of 6 minus 5 the whole square, 0 minus of minus 3, 0 plus 3 the whole square, 1 square plus 3 square, 1 plus 9 root 10 units. Equation 6. This is distance BD. What do I get from 1, 2, 3, 4? All sides are equal. What do I get from 5 and 6? Diagonals are also equal. So directly now I shall write down now from equations 1, 2, 3, 4, 5 and 6. Quadrilateral ABCD is a square. What is the reason, children? If all the pairs are equal and the diagonals are equal for a quadrilateral, all the pairs of sides are equal and the diagonals are equal, the quadrilateral is a square. So if you want, you can write down here, in a quadrilateral, if all sides are equal and both diagonals are equal, then quadrilateral is a square. We are not done with our sum. What is left, children? So as I said, I'm going to write on a different marker. Dash, 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 dash are the vertices of square. Therefore, A with 4 minus 1, B with 6, 0, C with 7 minus 2, and D with 5 minus 3 are vertices of square. Right, children? I hope you have understood. I hope you have understood this, and you understood the difference between square and rhombus also. Right?